Good afternoon. I seem to always get the dreaded just after lunch spot when I speak, so hopefully we can keep this engaging enough that this is interesting. So I'm expecting people to trickle in a little bit more here still. So we're going to talk about testing. So my background, I was a nuclear engineer in the Navy, submarine officer. And then after doing that for too many years, I went into semiconductor manufacturing, did that for a few years, didn't really enjoy that either. Ended up getting into programming. And first place I went to, someone's like, we need someone to figure out this selenium thing. And I'm like, oh, I'll figure out this selenium thing. So I started writing tests, and that kind of put me into the niche of a test automation engineer. And I did that at 4 different companies before joining Sauce Labs. And the other, kind of what I do on nights and weekends is open source coding. So I'm one of the core contributors to the Selenium project. Who here has heard of Selenium? Who here has written tests in Selenium? Okay, quite a few. That's great. So I own the Ruby portion of Selenium. Does anyone use Ruby? Nice. My friends. So I also am the project lead for Water, which is if you think of Selenium like a browser automation tool, you would think of Water as focused on testers and using Selenium in order to implement your tests in kind of more of a do what I mean approach rather than Selenium's do what I say. And we'll get to that a little bit more later in the demo, but that's what I spend my nights and weekends doing and have a lot of fun with it. So we're all familiar with waterfall. You've probably, how many people here would consider themselves a build engineer of sorts? Okay. How many people would consider themselves in the role of tester? Like that's your primary function? And then how many people are developers that write tests in some fashion? Okay, that's the majority. Okay, great. So we're all familiar with this idea of the traditional waterfall of you do all of your requirements up front and then do all of the design and then all of the coding. And this process really lent itself well to manual testing, specifically because because there were such long times between releases, you needed to make sure that everything was exactly the way it needed to be for your users, because if you broke something, you wouldn't be able to fix it for months. And so the feedback time was really long, and it doesn't scale. So I want to spend some time talking about some testing technologies that you may or may not be familiar with here, and kind of the progression of how testing has evolved over the past 14 years. So Selenium was first written in 2004. Water was actually before it was implemented by Selenium. Water was 2003. So it's been a while since we've had these automated tools, these open source alternatives to the large, expensive enterprise test options. So a lot of companies, when they start out, you've got your manual process. I like to call it a journey, essentially, because you're starting with, let's create a user, log them out, log them back in, create an address, view the address, edit the address, view the address, delete the address, view that it's not there. That whole process is kind of how a manual tester looks at something. And the first approach that when a manager says, now go automate this, is they'll do that exact same thing, only with code, because that's how they focus on what testing means, is to do this whole process. And oftentimes, because they don't know how to code, they will use a record and playback device like Selenium IDE. How many people here are familiar with record and playback devices in general, or Selenium IDE specifically? Okay, so essentially you would hit record, take all of your actions, it would create a list of actions that can be repeated. you hit end, and then whenever you deploy a new build, you can hit enter and have it run through all of these steps. And obviously the disadvantage of that is if anything changes anywhere in that process, you have to re-record the entire script. You have issues, especially as websites have become more dynamic. You have a lot of timing issues that make it difficult. And so I have not seen any companies that have a large, well-maintained test suite that has been written entirely in Selenium IDE. And so it's oftentimes, a lot of people have used it to kind of get started, but a lot of the dev tools in browsers are good enough now that you can right-click on an element and see what the locators need to be to figure things out. So I am not really a fan of using that as your primary focus. I think it's easier to just get started with the browser developer tools directly to write actual code. And so Webdriver was the Selenium 2.0, essentially. So Selenium was implemented with, it was JavaScript. You inject JavaScript, you take actions with JavaScript, and it obviously has the disadvantage of all cross-site scripting issues and things that you just can't do in JavaScript because of operating system interactions. And so Webdriver was an attempt to solve that by creating separate shims, a binary, a driver, that the code would interact with the driver, and then the driver would interact with the browser, and that allowed more low-level access. It was also it was more object-oriented, and so you would have a driver object with capabilities objects that would interact with the driver. It would interact with the browser to automate the browser activities. And this extra focus on more object-oriented approach actually helped encourage the use of page objects. People familiar with the page object pattern? A lot of people. So the idea behind page objects, and a lot of people still don't do this very well, is to distinguish your business logic or the actions, the intention of the feature from the actual implementation on the website itself. And so you want to specify what the element locations are and the actions that can be taken on a page, completely separate from what the business cares about or what your product manager cares about, which is just the higher level, the what versus the how. And so that became a big thing. And then mobile applications have come up, and we need to figure out how to test native mobile applications. Selenium is specifically browser interaction, and so native apps. So we've come up with Appium as an alternative to, it's essentially the same approach that Selenium takes, where you can write the tests in any language, and it will translate into what the driver needs to see in order to interact with the iOS device or the Android device. Has anyone here used Appium before? Okay. And so this is an important technology that needs to be included in your automated testing pipeline. And in addition to that, a lot of people end up relying on, so one of the issues I have with the way a lot of people approach testing and writing their testing code is they do everything from scratch. And so they'll write their own helper methods, they'll do their own base page implementations, and there are so many great open source libraries out there that have already invented that wheel and have had a lot of users interact with it. And the Ruby community, both because it embraced open source very early and because there was a lot of test-driven development focus in some of the early Ruby leaders, that Ruby has a number of really great open source tools like Capybara and Water, for instance. And they both try to solve the same problem of making it easier for testers to write tests. But you also have Cucumber solutions and BDD options and Robot Framework and Selenide and CLion. There's a lot of different things out there that make it easier to kind of get up and going without having to start from scratch. So an interesting thing as the build tools have improved, as the ways that we can run and execute these tests, I mean, automated tests were never designed to be their own thing. They've kind of, the whole point of them was to run them in a process to get from code to users. And as that process improved and became more sophisticated, the need to change how you think about testing has become much more important. And so instead of these long journeys that I described earlier that a manual tester would take, we need to transform beyond that and try and break it up into the smallest chunks to make sure that that functionality works. And so that means just testing the login, just testing the sign up, just testing the delete functionality without going through all of the other process. And especially as we're moving towards the Angulars and the Reacts, these actions all go through an API anyway. And so you can set things up with an API and then only use the browser for the one action that you care about. And what that does is it allows you to run many tests in parallel. So you can break up this 30-step process into the specific chunks. And what you care about is essentially testing the DOM to the database. What your user puts in gets to the database the way you want, and then back to the DOM. And along with this, it's important to recognize the problems with test data management. And this is something that build engineers also have to deal with quite a bit, is if you're trying to run tests in parallel, you have to make sure that the data that you are using for one test is not causing problems for the data that needs to be used for another test. It's really important for any test that you have a known state that you're starting with to make sure that the result is the same regardless of how many times it is run. And even for the same test, if you have a test that stopped halfway the last time, perhaps that data is not in the state that it needs to be for running the next time. And so ideally, you are creating the data you need when you need it in order to run each test that you're doing. So another important thing that we're seeing now is you can test the functionality of the site, and functionality actually between browsers and platforms has gotten a lot better. Chrome on a Mac is not that much different from Chrome on Windows, but we're seeing that there are a lot of issues with how things are displayed still between different browsers and operating systems. And so things like visual testing and making sure that one set of elements isn't covering up something that you need. I worked at a company that there was an issue and none of the images for the products showed up on the page. So Selenium very dutifully clicked the add to cart button and clicked the payment button and everything passed just fine. But a user's not gonna click on something without the image there to make it easy. And so something like an Applitools is a great product that's done a lot of really interesting things with being able to care about this part and don't care about this part. You essentially set a baseline and it allows you to automate a way that it's really reliable that when you get a failure, it actually matters. And then the last thing on this list here is continuous testing. And let's get to the next slide here. So I think we're kind of familiar with this process. I mean, it's essentially agile. We're trying to decrease to as short a time as possible when you're planning to writing the code, building, testing, releasing, and getting feedback from its operation in production to plan again. And the whole point of, actually, how many people here would say they do continuous delivery? Okay, well, actually, let me step back. How many people release about monthly? Right. And so how many people would say they release every sprint, like maybe every 2 weeks, give or take? Is there anyone here that's releasing daily? How about hourly? Okay, so this is the trend that we're trying to push the industry towards, is getting that feedback time as quick as possible to the developer. One of my coworkers at a previous company, we'd ask him about some code that he wrote, and he would joke, he's like, I don't know, I've slept since then. And maintaining context is really important. So if you can get feedback to the developer about something that they didn't do exactly right, or it affected some system that they didn't know about, if you can get that feedback to them right away, it allows them to maintain the context in order to fix it more quickly, rather than 2 weeks later, someone has to go in and then refigure out what's going on. And what we're finding is that this though, is not enough. That's not useful. Oh, it's dynamic. So what we're finding here is testing needs to be done at many stages in this process. When you're writing your code, before you build it, be able to run tests on it. When you have built your application, run tests on it. When you have deployed that application perhaps to a staging environment, run tests on it. When it's out in production, where your users are actually using it, run tests on it. And then you can get the feedback that you need to go through that process again. So this is a process. How many people here do feature-based development, feature branch-based development? Does anyone here do trunk-based development? Okay, so some people here. So this is a sample process that one of my colleagues put together that it's mostly focused on feature branch-based development. And feature branch, I'll explain that, is you essentially create a branch, you maybe you can do hundreds of commits on one branch. So everyone that's working on different features creates their different branches, and they do their dozens of commits, and then they merge it back into master. And one of the difficulties with that is person A working on feature A and person B working on feature B are making changes to the same code, and so you can have lots of issues with merge conflicts. The alternative to that is trunk-based, where everyone is constantly committing to master. And that prevents anyone from diverging too far from current state when they are writing their new feature. And then that requires feature toggles so that the code all of the code that has to be written, it's there in the code base, but it's not being seen by your users until later. So these are two different approaches to continuous delivery, and this one is more focused on the feature branch approach, but it can kind of be applied to trunk-based, and we can talk about that. And actually, so I'm going to do a demo with some live coding. Wish me luck. And we're just going to focus on this first part of executing a PR build, or doing a pull request and having it automatically kick some things off. So let us start. So we have just a simple app. I'm going to go ahead and start a server. And here we go. It's on localhost 8000. So here we are, just a simple app. And it's for entering data. Okay. Just this. Aha. There we go, except for now I can't see it. So we just enter more data here, and we add. All right, so here we go. We just added, so this is an Angular app. This is all in JavaScript. There's no service layer or database that's storing the stuff right now. It's just entering data at the JavaScript level. And so I refresh it, and this goes away. But say someone has a feature request that, okay, now I want to delete this data that we've added. So we go into our app, and first we need to add the button. So let's copy paste this. Of course I am. Thank you. Can everyone see this? Is this large enough or no? See if I can do this. Thought I turned it to 16. What do we have here? Is that any better? Did it change? Command plus. That's not seeming to work. Well, there we go. Is this better? Okay. So, oh boy. We don't need this part. Let's remove data. This is fun. Move last data, and then we need to change this. All right, so now let's go back to refresh on this. Oh. Yeah, IntelliJ automatically saves. It's a well, I don't really want to do this, but oh, there we go. Good call. Thank you. There we go. There we go. So now we have the button that doesn't do anything because we haven't written that part yet. Thank you for that. So we need to go to the controller and add controller information here, scope. I'm also not a JavaScript person, so this will be fun. Remove data equals function. So if my syntax is off, go ahead and shout it out. Actually, so this is going to be scope dot remove last data, and we need to all right, and then on the service, we'll get to that. Thank you. This dot remove last data equals function. And so we're just going to implement this with a data.pop. Semicolon, semicolon. Okay, so let's go ahead now, and we've got our service running down here. We're going to go ahead and get, well, let's check out a branch. Check out, let's be Jenkins world. And let's commit that as implement remove data. Okay. And the internet works? Yes. And so now let's go to GitHub here. This is why I didn't want to clear my browser history, because then I'd have to log into this. So let's do this pull request. We're going to take a look and say, okay, so the changes that we made. So let's go ahead and create this pull request. And what this is doing, so I'm using the pull request GitHub plugin. So it's a webhook that is going to automatically kick off a test on my Jenkins server that I have set up. So let's go ahead and on this. We can take a look at the progress of what we're doing. So essentially I have a make file that this is kicking off, and we can look at that in a second. But essentially it is loading things up. It's going to take a second. We'll see. I'll talk about Sauce Connect in a minute as for what that's doing. But so here it is doing the npm install, and it's running the JS hint. So this is, okay, so here we go. There's a failure. And why did it fail? Someone already called it out. There's a missing semicolon. And so the idea, this isn't like use this exact build process, but the idea is here are ways that you can decide ahead of time what things that you think your developers need to be focused on or doing as they are writing code and in this pipeline. And so for instance, in Ruby, this could be doing a Rubocop to make sure that all of the syntax is, like Ruby, you can do things a dozen different ways, but maybe you want a certain syntax to be enforced throughout your code base to make it more readable or easier for other people to use. You can put something like that in here. So let's go back to the code. And that was in the controller. And there's our missing semicolon. So, and obviously, you know, your IDE or whatever will probably catch that itself. But this is an example of a way that you can do that. So let us get commit am fix syntax. Okay, and so this is already an active pull request. And so if we take a look at, there we go. So if we come back here, we can see that fix syntax added a commit, and it's kicked this off again. And so we can take a look at, let's do this in a new tab. So let's look at our console again. And so this, after it does this the syntax check, it's going to run the unit tests. And so these are JavaScript-only tests. You are just running stuff in Angular, but we need a browser open in order to do that. So yep, there we see that the syntax was fine, and it's going to run unit tests. So it's going to run all the existing unit tests. And then we also have an additional check at the end of these unit tests to verify we added something for code coverage. So it's like, hey, the old coverage was 100% because this is a stupid small app. And the new coverage is only 90%. So you added a feature without adding coverage. So here's another check you can put in there to enforce that, and you can put other, like, it's okay for it to be 2% less or whatever it is. Your logic can be different. But the idea is you can add this as a check for this is something that's important that we as a dev team or, the group decide that we want to make sure that you are doing things the right way. And so I guess I should specify, anyone here use test-driven development, their companies? So I am doing this as a test-driven development for my build process, not for the code, if that distinction makes sense. And this can be bigger. Not that it really matters here. But so this is saying that the coverage is too small. So they're 190.48. So let us go ahead and write a controller spec for this. And so because I just cherry-picked this code because I didn't want to write it in front of you. But this is a unit test that we can add for removing the data. And this is essentially, you add the data. So this is designed to be just a JavaScript test. So this is just using Angular. One of the companies I used to work for, we used browser tests in two different ways. We had water tests for functional, complete DOM to database tests. And then we used Angular with Protractor for the Angular implementation for what I referred to as DOM tests. And so essentially, this is just within the browser. You still need to load the browser in order to make sure that your Angular actions are loaded onto the elements in the DOM, but you can mock out the interactions through the API. But you're still making an assumption. Assume that when I send this JSON blob to the API returns this JSON blob back. And it's entirely possible that tests written like that will pass, even though the system is broken, because you're only testing your expectations rather than your. So let's go ahead and push this. Go back to, so here we see we added the test. Let's go grab the details. There we go. It's the next build. Take a look at this. So it's going to run the unit tests again. And the unit tests are, in this case, the unit tests are actually getting run on Sauce Labs. And we're running it in 3 different browsers, on 3 different platforms, but essentially loading the browser and taking the actions just within the context of the browser, and then checking afterwards to make sure that the code coverage is good. So here we are running the unit tests, and then it's running on Sauce Labs. I guess we can take a quick look at that. So it's just running these Karma and Sauce Labs on the demo. And if you take a look at, well, and we don't have screenshots for this. So because it's all execute script. Let's go back. So what failed this time? Aha, so we also put in this additional check to say that where is the failure? So this is essentially returning saying that, okay, we have this, you added a unit test without adding a functional test. And so we're going to go ahead and add a functional test here. And we can see that, here we go. So this is the functional test that we're adding. And this is going to be the full go to localhost, find these elements, click the element, and ignore that that's XPath. And we go back to our GitHub. It adds the functional test. Close these. So here we see it kicking this off. And now once it gets to this stage, it's actually going to run a couple dozen tests. Come on, click. And so we can see all of these are going to kick off. And it's not, doesn't like my unit test still. All right, so this is what I ran. These are what I ran at 11:45 that completely worked. And you can see the test that we just added, going through and adding. Let's go ahead and skip forward. Here it is. It's going to click on the tab. It's going to add data. And then it's going to remove that data, and that test passes. So again, this is an example of how you can add tests into your pipeline. And this is a way that even if you're doing trunk-based development, instead of committing directly to master, maybe you're committing to this PR, and the PR is the gatekeeper between we don't know if you've screwed anything up, to we're pretty sure you haven't screwed anything up, so that when it gets to master, it can be deployed directly to production, and then you can be monitoring in production that no, really, you didn't screw anything up. And this is kind of designed to go to the next step of managing a collection of features before that you can test in a build system. If you looked at the test, we were hitting localhost. So essentially, it was a Docker container that was created and hitting localhost, and so we had to use a VPN, a Sauce Connect, in order to run it on Sauce Labs. But so just kind of an example of a way to include testing in your process, and obviously this scales, and you can run things run all of the things in parallel on different operating systems and browsers to get confidence that what your users are using, they're going to see what you expect them to see. So I also wanted to touch on where I see things going in the testing community. And obviously everyone is at a very different stage, and even in this room, of where they are as far as how often they're releasing and what things that they're getting from their UI testing, and just testing in general. And what the next things coming up. Right now we're collecting all of this data. And obviously collecting data isn't enough. You need to figure out what you're going to do with the data. And so a lot of companies create their own dashboards to try and collect data and put it in a usable format with charts that their managers can see and understand and be happy with. And a lot of times that comes, one of my companies I worked at, we did that through the Jenkins API. You can get a lot of information from the Jenkins API and populate a really nice Angular app. Sauce Labs is coming out with this analytics to try and give you more information about in the last 7 days, what tests have passed or failed, what are the builds, the same test within a build, how is that done? Essentially giving you information for you to manually take action on it. It still requires you to be able to go in. And this is something I do want to point out. A lot of people have the misconception that the most costly part of writing tests is creating the tests. And so you'll have managers, coverage, keep writing more tests. And the problem with that is the most costly part of testing is the maintenance of those tests. It's making sure that when something fails, it's a real problem and not a flaky intermittent test for timing issues or for we changed a locator somewhere and didn't update things. And so kind of the next level after this, some kind of pattern matching. So say your testing service, which is collecting all of this data about your test runs, say, hey, the last dozen times that you ran this code, it passed, and the 13th test run or the 100th test run of this, it failed. Well, we've been keeping up by taking a look at what your DOM looks like in each of these tests, and the time that it failed here, the DOM is different. Maybe we have enough information to look at the DOM and say, this locator changed, or there's a different thing here. Most likely what you want to do is click this instead of this, and your testing service can do that for you, or rerun it knowing that something is going to change in there automatically. So the idea is to go from the idea is to be able to provide you, first of all, more information so that you can make changes. Maybe we tell you this is likely to be a brittle locator, this crazy long XPath. You change anything in there and it's going to break. But maybe the next step we can figure out, hey, this crazy long XPath, we see that this extra thing changed, so let's add that little extra part in your XPath, and now everything is going to pass. But finding ways to do things for you automatically and finding ways to be intelligent about fixing things for you automatically. And then one step beyond that is the idea of not having to write any code. So either a machine is smart enough to take a look at your website, understand its functionality, and take actions, write the tests for you that it knows you need in order to make sure that all of the functionality works, filling forms and adding things to cart. But this is ways in the future. And I know that there are a number, and I don't want to confuse people, there are solutions out there that say you don't need to do any coding in order to write your UI tests. And again, from my experience, I have not seen any large-scale testing implementations that are easy to maintain that don't use developers writing code. And that's an important thing. And even developers writing code. So a lot of people in here say that they're developers and they're having to do UI tests. Oftentimes, the people who have experience writing tests, your SDETs traditionally, your software development engineers in test, have experience putting together a framework and knowing the pain points of here's how you do your weighting strategies and this is the way you wrap your elements to make sure that these actions take place the way we expect. A lot of developers haven't had the experience to learn that. So a lot of developers are being given the task, you are now responsible for the quality of your code and you have to write these UI tests in addition to your unit tests. But make sure, it's important for companies to recognize that there is a skill set and there is a learning curve to this. And there are companies out there that are like, we're going to make our devs do this, and then it doesn't work, and so they scrap it. And there's knowledge that's out there that can be leveraged, and it's not trivial, but those are the kinds of things that developers in the process are going to need to learn as we're moving towards having separate siloed QA departments and having that stuff merged into one group that is immediately responsible for the quality of their code. All right, so that's everything I have. Does anyone have any questions about these things? Everything I said was completely understandable and yes?
On your SauceLab dashboard, it showed the number of tests. What framework were those tests run in, and how did SauceLab pick up those tests?
So essentially, we can show the makefile here. I can find my mouse. So essentially, it is kicking off. The functional tests are, the shell script is essentially, so essentially you've got a desired capabilities file that you're running with Selenium. In this case, it's Protractor. And essentially, it's saying, point to this URL at Sauce Labs. And the question was, how does Sauce Labs know what to be running here? And it's just executing the code that will kick off the test, whatever your test runner is. But yeah, so like normally you would run, traditionally people would run locally, or you would run it on a grid in-house. And so there's just a URL that you're saying, run the tests at this URL, at this port. And you just change that to be Sauce Labs with use this operating system in this browser with these versions. And it will pick that up and essentially like a grid, figure out, start a brand new VM, run those tests, and report results back. That answer your question?
Yeah, you're using Sauce Labs to do the test running, but like you could be in Node, you could be in
Yes. The code doesn't matter. Essentially, all Selenium is taking the language of your choice, and there's 5 supported languages, Ruby, Python, .NET, Java, and JavaScript. Taking those languages and the idiomatic ways those language works and translating it to JSON blobs. So essentially your grid or your Selenium server or Sauce Labs, they're just getting these JSON blobs and based on what's in there, figuring out what to do, and then sending it to the driver on the remote machine, and that driver is interacting with the browser to take those actions. Is that a better answer?
Yeah.
Okay. All right, who else?
How seamlessly can I switch between our local grid versus Sauce Labs?
If you have a local grid, it's literally just a matter of changing the URL and then adding the parameters that we specify on our site for desired operating system and browser and versions. It's very seamless to change that. And it's easy to get a free trial and test it too. So. Okay. Who else has a question? It's hard to see. Anyone else? Okay, I think we're good then. If anyone has any questions for me, I'm going to be around at the Sauce Labs booth for a while, and especially any Selenium questions or testing-focused questions. I spend a lot of time on Stack Overflow and in the chat rooms anyway, so feel free to hit me up. Thank you.